Hey guys, very good evening to all of you. I'm Pushkar Ranjan, bearing USN number 1BE20CS119, currently studying in 7th semester in the Department of Computer Science and Engineering at SPC Bangalore. The subject for which we are going to see this session is for cryptography, and the subject code is 18CS744. So let's begin. Contents. What are the different topics today we are going to see in the video are number first, what is encryption? Second, different types of encryption and differences among them. Third, symmetric key distribution using symmetric encryption. And fourth, key distribution scenario. So let's begin them one by one. Number first, what is encryption? In cryptography, encryption is the process of encoding information. This process converts the original representation of the information known as the plain text into an alternative form known as ciphertext. So here in the diagram, I have made the diagrammatic representation in which you can see this is the text, which is also called as the plain text. We have to convert this into the ciphertext. For that, we are going to give different keys to the plain text, which will convert them into the encrypted data, which is known as also ciphertext. Next, types of encryption. So basically, we are having two types of encryption. Those are symmetric encryption and asymmetric encryption. And here we have some differences among them. Number first, smaller ciphertext compares to the original plain text file. In asymmetric encryption, larger ciphertext compares to the original plain text file. Second point in symmetric encryption is key size varies from 128 to 256 bits, whereas in asymmetric encryption, the key size is 2048 bits. Third point in symmetric encryption is used to transmit a huge amount of data, whereas in asymmetric encryption, it is used to transmit the less amount of data. Number fourth, in symmetric encryption is less secure due to single key during encryption, and in asymmetric encryption, it is much safer than symmetric one as double keys are used during encryption and decryption. Number fourth point in symmetric encryption is algorithms applied like RC4, AES, Quad, etc. Whereas in asymmetric encryption, the algorithms are RSA, ECC, etc. So the next topic is symmetric key distribution using symmetric encryption. For symmetric encryption to work, the two parties need to exchange the same key, and that key must be protected from the access. For the two parties A and B, key distribution can be achieved in number of ways as follows. Number first, A can select the key and physically deliver to B. Number second, a third party can select the key and deliver it to the A and B. Number third, if A and B have previously and recently used a key, one party can transmit the new key to the other, encrypted using the old key. And number four, if A and B has encrypted connections to the third party C, then C can deliver a key on the encrypted links to A and B. So here I have made a diagrammatic representation for the key distribution scenario in which we are having the three stages: initiator, responder, and key distribution center, that is KDC. Now what actually happening in this diagram is A generates a public or the private keys which are known as PUA and PRA. As you can see, the public keys and the private keys. This is the public key, PUA, and PRA is nothing but the private key. And transmits a message to B consisting of PVA and is the identifier of A, IDA. So this IDA, as you can see here, it is nothing but the identifier for the initiator as A. KA, KS, these are all the keys. And N1 is known as the nonce. Whereas the A is sending the keys and the identifier to the key distributor center, and it returns the encrypted data to the initiator, and then it transmits the encrypted data to the responder, that is P. So how it actually works, let's see them one by one. The distribution Before we discuss the actual working, we should know about what is key distribution center. That is the this part, which I'm going to highlight in the square shape. So we will see this first. The distribution of key distribution center is based on the use of hierarchy of keys. At a minimum, the two-level keys are used. Second, communication between end systems is encrypted using a temporary key offered as a session key. Third, typically, the session is used for the duration of logical connections and then discarded. And number four, master keys shared by the key distribution center and end systems encrypt the session keys. So now let's see the working of the scenario. So here, let us assume that the user A wants to establish a logical connection with the user B and requires a one-time session key to protect the transmitted data over a connection. A has the master key, which is known as the KA, known only to itself, and the KDC similarly. B shares the master key, which is known as the KB, with the KDC. KDC is nothing but the key distribution center. The following steps should be followed as number first, A should be a request to KDC for a session key to protect a logical connection to B. The message includes the identity of A and B, a unique identifier. N1 is nothing but the nonce. N1 for this transaction, which we prefer to a nonce, as I mentioned the name earlier. A nonce may be a timestamp, a counter, or a random number. The minimum requirement is that it differs with which it requests. Number second, the KDC responds with a message encrypted using KA. Thus, A is only one who can successfully read the message, and A knows that is originated at the KDC. The message includes two items intended for A. Number first, the one session key KS to be used for the session, and the original request message, including the nonce, to enable A match this response with the appropriate request. Number third point, using the newly minted session key for encryption, B sends the nonce N2 to A. Number fourth, also using KS, A responds with F of N2, where F is nothing but the function that performs some transformations of N2. So these are the steps that assure that B, the original message received, was not on a replay. So I would like to conclude my presentation over here, and thank you. See you guys soon. Bye.